Hi, this is Dr. Roger Hannegriff, and today we are talking about input-output analysis. This is part of the agribusiness pathway, and it's an area that we look at called cost analysis. All right, so what do we know? And by the way, I want you to write down the information that I have on the board as we work on it. Being an active learner will help you remember the content. Also, along the way, I'm going to drop some questions that are going to be things you ought to be able to learn from this lesson. So hopefully you'll catch those as well and can refer to them in your notes. All right, here we are. This is what we've got. As an alfalfa producer, I have different production levels of alfalfa that I can achieve per ton. Now I have an input, and in my example is lime. In fact, this lime input is called a variable cost because if I use 2.2 tons of lime per acre as an example, I get 3.445 tons of alfalfa. If I go to 2.3 tons of lime, so more, I get 3.4941 of alfalfa. I get more production. So as a variable input, the more we use of it, the more production goes up. Now, not all inputs like lime always make output go up because you would never stop putting lime on. The truth is at some point, too much lime will cause production to go down. Those are irrational stages of production. So I'm focused right here on stages that actually do make sense. I have decisions. How much lime should I use? Because the more I use, the more production I get. Well, how do you make any good financial decision? You need two things. You need a cost and a revenue. So I've got those right here. Your input, and that's one of the other things to notice in this work, is what is the input and what is the output? Well, couple of ways easy to remember that. If you're an alfalfa producer, alfalfa is what brings you money in. That means that's your product. That's what you sell. That's what your production is focused on, growing alfalfa. So that's money in, that's value in, that's the product. What is the input used to get that product to happen? Well, in this case, it's lots of inputs like water and fertilizer and other insecticides and herbicides and tractor time. But in my case, I pulled out one called lime, and that is the money out. I've got to buy the lime. And in this case, it's $50 a ton. So if I can use this $50 per ton, and I've got different choices. This is going to cost me more than $50 because it's 2.2 tons. This costs more, this costs more, this costs more. So this is my input. It's the money I spend, $50 per unit. But I get more and more production, and it's worth $125 a ton. So you may say right away, I know the answer. It's more alfalfa production, so more tons of lime. Well, these are all separate decisions to make. And so what we do is, in farm management, we perform analysis, and that's what I'm going to step you through. What are some ways we can analyze this production? Well, the first way to analyze the production is the most common, and it is called average physical product. In fact, I'm going to draw in my notes here a little line over to the side, and this is basically our average production. So I'll put a little R in there. Average, little A in there. Average production, and that's called average physical product. Well, averages are pretty easy. They're just a number divided by a number. So I'm going to run down here to the bottom of my column, and it's going to be somewhere in here. And what is the formula for average physical product? It's easy. And I'm going to call this my quantity, and I'm going to call this my input, so I can use those. What you do is you just take your quantity at each level and divide it by your input quantity, and that is average physical product. So I've already got the answers done here, so I can go ahead and tell you what they are, but they're easy to calculate. You're looking at 3.4452 divided by 2.2. If you do that with me, that's going to be an average of 1.566. Now, what does that 1.566 represent? It represents the quantity, which is what? Alfalfa tons. So 1.566 tons of alfalfa divided by whatever the input was, which is 2.2. So what is this? In my first example here, let me draw a little arrow over. This is 1.566 tons of alfalfa per, now since it's divided, it's 1 ton of lime in my case here. All right, now why do you say it's 1? You're like, hold on a minute, it's 2.2. But remember, I took 3.4452. I took that and divided it by 2.2. 2.2 tons of lime altogether in the truck by itself is going to give me a bigger quantity of 3.4452. But I want an average. So when I divide it, this number gives me the average per 1 unit of the input. That's what an average does. Every time you do an average, whatever's on the bottom, the answer is 1, and then whatever's on the top is the result. One of these gives me that, and that's what that answer is. So that's 1.566 tons of alfalfa for 1 ton of lime if you use 2.2 as the rate. Now, if you use 2.3 as a rate, you get a different number. Let's go look at that. And that goes to 1.519. So actually, my average drops. My total goes up, but so does my input. So the average is 1.519. Now you may say, oh, hold on a minute. I don't want to go any further. That's the highest average. But you could be leaving money on the table, because I'm interested in getting as much of this input in as I can to give me that much money there. But I need to watch how much I spend. What's the ratio? We haven't gotten to that. We're just looking at production. So we haven't talked about money yet. This is just quantity. If we go to the next level here, move a little faster, the next level is at 2.4, and that's going to be 1.474. And then if we go to 2.5 level, that's going to be 1.430, just to help you calculate those. All right, that's called average physical product. You can see the average 1.56, 51, 47, 43. The average is dropping. And so you might be tempted to say, hold on a minute, we're not going to make any money now. The average is dropping. But remember, the production quantity is going up. So I don't have an answer yet. Plus, it's about measuring money in and money out and figuring out the best formula to make up the most profit. So we got to keep going. But average physical product is a great number to measure and identify. It might help me in budgeting about how much alfalfa I might produce if I choose different quantities. Helps me look at my production estimates. Average physical product's important, but it is just an average. Now, what's another way to analyze our work? And this is called marginal physical product. It's called MPP, and this measures the change. In fact, the change and marginal are the same words. So marginal, or change, is trying to look at, I already know the answer at 2.2. It's 1.566. But can I measure, is it worth going from 2.2 to 2.3? And that's what marginal does. So what I'm going to do here at this first row is I'm just going to mark this out, because I am no longer looking at a level. In fact, if you want to take your formula down here, this is the value at a particular stage. This marginal analysis, the formula is the change in quantity. How much did my quantity change by? The change in the input. And that's the formula for marginal physical product. Pretty much the same formula, except we're not looking at a level anymore. We're looking now to measure the change. And so that is the next stage. All right, so here we go. We've got the concept, we've got a column. Let's place our answers in it. Now, to get these answers, we need to do a little math. First of all, what does it take? When you go from 2.2 to 2.3, it takes 0.1 of a ton. So 1/10 of a ton is the extra we've placed to go from here to here. The next question is, what does that do from a yield standpoint? And again, I've got the answers to these, and the answer for this one is, it is 0.0489. It goes up just a little bit, 3.44 to 3.49. That's 0.0489. So if you took that number, the change in quantity, right? And divided it by the change in the input, then you will get a new number, and that's going to be 0.489. Basically moving the decimal over a little bit. Now it's the same concept. Just like this represented the production at a level, this represents the production when you change a level, but the divisor is still input. So it's per 1 unit of lime. Remember, we're going from 2 to 2.3. These are the big changes. This change is really measuring each unit, but the result is still divided by 1, just like this number was. So this is 0.489 is the increase for every 1 ton of lime when you go from here to here. Now, if we keep going 2.3 to 2.4, that gives us a change, again, from, oops, not from this level, from this level to this level. That's going to be a 0.0431. Same deal here. We're looking at, oops, I messed up. Sorry about that. So if I watch yours here, we're looking at the change actually from this level to this level, and that's our level there. It's 0.1 again, and then this was 3.41 to 3.5372. That's going to be a 0.0431. That's what that change is. And in fact, it may help us to do all of these together. The next one's going to be this change. That's again 0.1, and this next one's going to be 0.0373. So our changes are all now noted, and that's how we should have really done that instead of one at a time. Now that we know the changes, we can do the math. So we've already done this first one. What's the next one? 0.0431 divided by that. That is a 0.431. And then you do your next one, 2.4 to 2.5. That's 0.0373. That's just 0.373. So now what we know is that if you change from 2.2 to 2.3, you go from a level that brings you 0.489 tons of, again, alfalfa per how many tons of lime? Just 1. All right, next one, the change. Now, our growth, it goes up, but the change is still positive. All of these are positive numbers. So we're in good shape, but it's not as big as the last one. So you may say again, stop production, not making any more money now. But remember, it's about money in and money out. And this is not about money. This is about quantity. So we don't really have an answer for that yet. But we do see that the change in production is dropping. Now, if our alfalfa is worth enough, then maybe the input is not as expensive as it could be, and so maybe these are still good decisions. Once again, we don't know until we start putting money to it. But now we need to do that. All right, so average physical product, marginal physical product, they measure different analysis values. In fact, average gives you the production at a stage. Marginal gives you the production when you change a stage, and those are questions as well. All right, let's go across here. What do you need, and I've already told you, but what do you need to determine profit? Because that's what we want to look at now here. Where are we going to be profitable? Well, to measure profit, you need 2 things. You need a revenue and a cost. Again, a review of something you should get out of this. So I need to do profit analysis. However, I don't have all my inputs. I just have one. I do have my production, but it's only relative to the one input. Other inputs like water might give us different quantities. That's a different analysis. So in input analysis, when we talk about profit, we typically look at something called, and we're going to use the marginal. In fact, by the way, marginal is really the most valuable type of analysis. Average is great, but marginal tells you the decision that you need to make. Should you go from here to here, here to here, here to here? Once you're at a level, the next question is, what else could you do? So is there opportunity cost out there? That's a term. But we're going to go ahead and decide that based on analysis. I'm going to come up with a column, and I'm going to call it marginal value product. And I'm going to put above it value as a term. So what marginal value product is, just like in sport games, it's the MVP, most valuable player. Marginal value product is giving you the value of the change. So that's how I want to look at it. The value of the change. And that value of the change is kind of connected to the $125 that we talked about here in our alfalfa. So how do you come up with this marginal value product? It's easy. You just take the marginal physical product and you just multiply, this little asterisk is multiply, you just multiply it times whatever the tons were worth. So that's $125 in value for each one of these, and production actually is going down. The change, quantity is going up. The change is going down. But we can multiply these across, and I've already done the math for that, and let's go do those. When you go from 2.2 to 2.3, that gives you a change of 0.489, and that change is worth, it looks like, $61 and, make sure I get this right, 13 cents. Taking $125 times almost right at nearly 50%, that's about right, $61.13. That's what it's worth. Well, before I keep going, well, let's keep going. Let's keep going down to the next decision. 2.3 to 2.4, that's got a value. The quantity changed, went down. The change is only 0.431. Multiply times 125. That change is going to give you a value of $53.87. So I want to put that one on there. All right, let's go down to the next one. Change keeps going down, and in fact, 0.373 times $125. Now our marginal value is going to be $46.63. All right, so those are the values. That's what we have as a worth. Now remember, all of this has been based on 1 ton of the input. Even the value of the change, you're taking a formula that's the value quantity for 1 unit of input, and you said what it's worth. So that value is for 1 unit of input. Well, in our problem here, what is the input? It is lime. So what is lime going to cost us? Every ton's going to cost us how much? $50. So the other cost in here is called marginal input cost. And basically it is our cost per unit. Well, what is that cost per unit? Every ton of lime is going to cost you $50. The next level of production, the production per 1 ton of lime is worth $53. So you compare it to what that what that lime would cost. That's another $50. What about the production for 1 input and its value at the next level? It's $46, but that's going to cost you $50. And so we are looking now to make a decision. Which one of these gives us the most value for our business? Well, if I go at the first level, 2.2 tons of lime to 2.3 is going to be worth about $61. And you've got to spend $50 to get that. So I'm going to put a great big old check, like I would do that. I'd spend $50 to get 61 back all the day. Just keep repeating that. But you can't keep repeating it because your next decision is 2.3 to 2.4. That gives us a gain of 0.431. That brings us $53.87 back. Once again, I like it. I would keep doing that all day long. Now, I already have captured this gain. Like I put this extra money in my pocket, and if I produce enough alfalfa across the field, I might make a good living at that. But if I decide to go to the next level, is there more profit to add into your pocket? The answer is yes. There's $53.87 of value to get back when you have to spend that $50 out. So actually, I'm in good shape. Next level, 2.4 to 2.5. Now this kept going and there was more decisions above. I just grabbed the middle. 2.5, that's going to make my production go up by 0.373 for 1 ton of lime. All the tons give me a bunch more. But the division here gave me per unit of lime, and that gives me 0.373. Multiply that times the money, that's worth 46 bucks. I am not going to go to that stage. I'm going to stop. So what is your answer? Well, your answer is somewhere between here is going to be my best decision, because you are going to use inputs like lime all the way up until your marginal value product equals your marginal input cost. And that is the formula, or that is the equation for maximum profit. So let's review what we've got here. We've got an input and an output. And inputs are the money you've got to spend. Output is the quantity you sell. That's the money you get back in. So you spend money to get this back. That makes this the input, that's the output. Inputs are a variable cost kind of decision, because I need to decide how much of this should I use, and it's relevant to how much I can make in alfalfa. When I do some analysis, the averages tell me the value at a stage. The marginal tells me the value as I make decisions to move from each level to each level. All of these values are per 1 unit of the input, because that's on the bottom or the denominator of my equation. So everything's based on what 1 unit of lime will give me. There's the average at a level. There's the value if you change a level. Well, this change is called marginal, and that actually is really one thing we're after. So what's it worth? Well, these marginal products, you multiply it times what you're bringing in, give you the value. And these values are a change in stage. So if these values are higher than my cost, then I end up wanting to keep using more of them until they get to a point. If I go back and look at this stage, that's going to be somewhere between 2.2 and 2.3 was an easy decision. 2.3 to 2.4 was an easy decision. 2.4 to 2.5 is a no-go. So I'm going to go back over here and say that my answer is somewhere between there and there. And so that is the connection of maximum profit. Marginal value cost equals marginal value product equals marginal input cost. All right, a lot of things to work on. Hopefully you took good notes. Go over that, and hopefully you can answer the questions that I've asked along the way. Thanks.